Children, listen. Chapter number 3, exercise 3.3 continuation, question number 9. So here they asked to find actually two things. In the last question, we have seen that a plus a dash they asked to find, and a minus a dash they asked to find. And they asked to say this will be symmetric, and the next one will be skew symmetric. Okay, that we have seen. But here what they are doing, they are multiplying 1 by 2 in both the case. That one they asked to find, but they didn't ask to check whether it's a symmetric or skew symmetric. Just they asked to find. That's it. Okay, right. So that a is given, so a dash we have to find additionally. So a is given. Sorry, a is given. In the given, you just write. Children, listen everybody. 0 a b minus a 0 c minus b minus c 0. So this will be a, and what they asked to find actually a plus a dash into 1 by 2. Okay, so that first you find a dash, children, means a transpose. A transpose na row we have to write as a column. This row we have to write as a column, means vertically we should write 0 a b. Like that, the second row you write as a second column, minus a 0 minus a 0 c. Like that, third row we have to write as a column, minus b minus c and 0. That's it. This is our required, what is that, a dash. Let it be as it is. Now they asked to add a and a dash. Later we have to multiply 1 by 2. Means 1 by 2 will multiply later. First you add a plus a dash we have to find. A plus a dash we have to find. A value 0 a b is given, minus a 0 c is given, minus b minus c 0 is given, plus a dash we have to write here 0 minus a minus b, a 0 minus c, b c 0. Children, corresponding element we have to add, means first element to first element we have to add, and second element to second element, like that third element to third element. All those things we have to add. Shall we add pa? Right, let's go, listen. So first 0 plus 0, next second element a, here second element minus a, third element b and minus b, so that b and minus b, right. Like that, minus a plus a, minus a and plus a, 0 and 0, 0 and 0 you will be getting, right, fine. C and minus c, c and minus c, minus b plus b, minus b plus b, so that minus b plus b, minus c plus c, minus c plus c, 0 plus 0. Here what is that c? Right, fine. Children, listen, everything it became 0 or what? Yes. So that 0 0 0 0 0 0 0 0 0. That's it, children. 0 0 now we can write that like this. So this is our required a plus a dash. Suppose if you are multiplying by 1 by 2, what will happen if you multiply 1 by 2 on both the sides? 1 by 2 a plus a dash, which is equal to 1 by 2 into 0, again 0, so that it will be 0 only. Okay, that's it. This is they asked to find, right. Like that, the one more one, they asked to subtract actually. They asked to subtract, so a minus a dash. So a value we have a 0 a b, minus a 0 c, minus b minus c 0, and they asked to subtract a dash. Krishna, what is a dash ma? Can you tell me? Tell me da. Tell me, are you telling row wise or column wise? Tell me. 0. Okay. Next. Okay, thanks. Sit down. Right. Karan, can you help me to subtract these two matrices? Actually, what we have to do here? Subtracting two matrices. Before that, we have to do one thing. What? Yes, minus A, we have to multiply inside. The name is called what? Scalar multiplication. What it called a scalar multiplication. Don't say just scalar. Sit down. Scalar multiplication. This minus we have to multiply with a each term of the matrix. Sorry, each term of the element of the given matrix. Understand? Right. That I'm gonna do here. So that 0 A B minus A 0 C minus B minus C 0. If you product the scalar product, if you do now, what I'm getting opposite sign, whatever we have inside the matrix. Okay. So 0 minus A minus B plus A 0 minus C plus B plus C 0. I have multiplied now. Then I'm going to add everything. What I will be getting? 0 plus 0, A plus A, B plus B. Corresponding element I'm adding. Okay, like that, minus A, 0, 0, C, C. Same manner we have tried to even second row also. Understand? Right, let's go now. What is that? Minus A, 0 plus 0, C plus C. Same manner, minus B, minus C, 0 plus 0. Okay, if I do now, what I am getting here? 0, 2 times A, 2 times B, minus 2 times A, minus 2 times B, 0, minus 2 times C, minus 2 times, plus 2 times C, 0. That's it. You can stop your answer here. That will be A minus A dash. Suppose if you multiply 1 by 2 on both the side, suppose if I multiply 1 by 2 on both the side, now 1 by 2 means what? Divide 2. So divide means each term must be divided by 2. Each term must be divided by what? 2. If you divide by 2, what you will be getting? If you want to do step, you do not issue. So that 0, A, B, minus A, minus B, 0, minus C. So this is you will be getting. What actually that is? Again question or what? Yes, again question. This is I'm getting again a question. So if you see, if you want, you can mention which is equal to A, or else you can stop, not issue. So these two answer we have done. So here we are getting 0. Here we are getting the same question after multiply by 1 by 2 on both the sides. Sir, 1 by 2 I didn't show. Okay, here you have to divide it 2, divide 2, divide it to all the place, divide it 2. Divide 2 you have to do. Then only you will be getting this step. Understand? Then only you will be getting this step that I didn't show. If you want, you can mention, not a issue. Understand? Right. Right, Raja. Question number 9 is over. Do fast. My next question number 10. 10th one will go. Boy side is anyone writing pa? Girl side pa? Done. Right. Question number 10. My question number 10, there is some subdivisions. Question number 10 says what? Let's see. Pa, listen, pa. So express the following matrices. Pa, this will be 3 mark. They may ask 3 mark. Okay, va. Or if you have a good luck, na sometime 5 mark. But 2 by 2 cannot be in a 5 mark. 2 by 2 cannot be in a what is the 5 mark. 3 by 3 matrix if they asking na, that may come in a 5 mark. Okay, or else this will be 3 mark question. Understand? Express the following matrices as sum of symmetric and skew symmetric. Listen, children. Sum of symmetric and skew symmetric I have explained when I have explained the theorem number 2. Listen, 1 by 2 a plus a dash, 1 by 2 a minus a dash. This is the symmetric portion. This will be skew symmetric, I said. When you add, you will be getting the a. Okay, the 1 by 2 will actually 2a you will be getting. When we have a 1 by 2, it will cancel. Have you remember? That is they are telling. The matrix A, we have to express in the form of sum of symmetric and skew symmetric. They are telling sum of symmetric and skew symmetric. So sum of symmetric, skew symmetric word if you have seen now, you have to remember this one. A plus a dash into half like that, half of a minus a dash you should find. Then you have to show that when you add both it's coming a. When you add both it's coming a. So you find this one, take p. You find this one, take q. P plus q when you add you should get a question. That is you want to do here. Understand? Shall we pa? Right. So very important question pa. Raja, we'll start now. What is that? The given one you take, let a equal to 3, 1, 5 minus 1. This is I'm taking a and a, just given one I have taken as a. Then what we need to find a symmetric, skew symmetric, a dash also need. So you find a dash also. Listen pa, a dash means what? A transpose. Yeah. So you row you write as a column. So 3, 5. Next this one if you write a column, yeah, 1 minus 1. This is my a dash. Now what is your work? Actually, first you want to find a plus a dash. First you want to find a plus a dash. So that a is what? 3, 1, 5 minus 1 plus 3, 5, 1 minus 1. When you add both, what you are getting? 3 plus 3 what pa? 6. 5 plus 1 6 again. 1 plus 5 6 again. Minus 1 minus 2. So this is the addition. So addition I did directly. See what I did? 3 plus 3 6. 5 plus 1 6. 1 plus 5 6. And minus 1 minus 2. Sir, I did directly. Addition I didn't show the step. Is it okay? Right, sir. Now a plus a dash we have done. Same manner, what we have to find? Half of the a plus a dash you have to find. Means 1 by 2 into 6, 6, 6 minus 2. 1 by 2 if you multiply inside like a scalar, it will be divided with each element of the matrix. So that what you will be getting? 6 by 2, 6 by 2 you will be getting, I'm right. So after divided by 2, what you will be getting inside? 3, 3, 3 minus 1 you will be getting. This is what actually half of the a plus a dash. This one you take what? Letter P, matrix P. Okay, matrix P now it should be as either symmetric or skew symmetric. What is the chance to be? This is P. P can be, the matrix P can be what actually? Yep, either symmetric or skew symmetric. Symmetric na, because we added means it must be what? Symmetric only. Okay, so we have to show it is a symmetric. How you will show it is a symmetric? If you take a transpose, you should get the same. Amava. So you take the transpose. So P dash is equal to 3, 3, 3 minus 1 whole dash. Okay, means transpose I'm taking. Row if you write as a column, na, this row I'm writing as a column. So what you will be getting? 3, 3. This one you write as a column, 3 minus 1. 3 minus 1. See children, we are getting the same. Then P is symmetric. P is symmetric matrix. Okay, symmetric matrix you have to say. That's it. Understand? Right. Sorry. Symmetric matrix. Right, pa. Symmetric matrix we have done. Same manner, what we have to find? Even A minus A dash. Q symmetric also we have to find, because we have to add both and we have to bring a question. That is they said, right? So that you should find even A minus A dash. A minus A dash you have to find. A minus A dash. So A value here we have A value, and A dash value here we have, both we have to subtract. So 3, 5, 1 minus 1 minus A dash value what? 3, 1. Yeah. 3, 1, 5 minus 1. Sir, if you subtract, what you will be getting? 3 minus 3, 5 minus 1, 1 minus 5, minus 1, minus and minus, plus 1. Which means 0, 4, minus 4, 0. This is I'm getting, that I'm taking as a Q, matrix Q I'm taking. So after taking a Q matrix, sorry, don't take Q here. We should multiply 1 by 2, no, that I forget. Multiply 1 by 2 on both the side. So 1 by 2 if you multiply, what I'm getting, A minus A dash is equal to half into, show the step first, 0, 4, minus 4, 0. If you multiply the half inside, it will be divided by 4 each element. Sorry, divided 2. Divided 2 if you do now, what I'm getting? Yeah. So 0 by anything 0, 4 by 2, 2, minus 4 by 2, minus 2, 0 by anything 0. So this one I'm taking as a Q matrix. This one I'm taking as a, yeah, Q matrix. Now Q must be either symmetric as Q, we have to check. For that we should take transpose only. Transpose when I take, what I'm getting? 0, 2, minus 2, this one, if I take transpose now, row will become a column, column will become a row. Okay. So 0, 2, and second row if I write as a column, minus 2, 0. Now see, if this is this a Q? Is this the Q as it is, whether we have or not? No. So for that what we have to do? Take negative outside. If you take negative outside, if you take this negative outside, plus 2 you will be getting, here minus 2, this will be 0. So finally Q dash is equal to minus Q we are getting. Q dash is equal to minus Q. Then what we can say? Then Q is skew symmetric matrix. Okay, that's it. Okay, right. Now we got what is that, symmetric matrix as well as Q symmetric matrix we got. Now we have to show that sum. Okay, the sum is what? Question we have to show. The sum is what? Question we have to show. Shall we go? Sum. So that now you show that sum is equal to what? P plus Q. P plus Q. What is P actually? Half of A plus A dash. Okay, if you want to write that, you can write, or directly you just show R 1 by 2. Don't want to mention, leave it. Already we have taken name now. Then you write what is the P value? Where I mentioned the P is what? Here I have mentioned. Yes. What is that? 3, 3, 3 minus 1. What about Q? Q here. Sorry, that's not a Q. Q here. Okay. Yes, what is that? 0, 2, minus 2, 0. That is the Q. If I add, I want to get question. If you get a question, we have done a correct job. Okay, right. So 3 plus 0, 3 plus 2, 3 minus 2, minus 1, 0. When I add, what I'm getting the Raja? 3, 1, 5, minus 1. Is this my question? Yes. Then what? We got a correct answer. Okay, sum of symmetric and skew symmetric is a matrix they asked. So sum of that we got a question. Hence what is that, verified or checked? Okay, hence proved. I'll just write hence proved. So the same thing we want to do in a 3 by 3 matrix also. See, for 2 by 2 it has taken time. this much time. 3 by 3 na it takes little more again. Okay, that is what I said. 3 by 3 na it may come in a 3 mark or 2 mark question, but 2 by 2. 3 by 3 na may come in a 5 mark or 3 mark. May come in a 5 mark or a 3 mark. If you are very clear, you can avoid steps. If you are very clear, you can avoid steps. Do fast pa. Next, in the 10th one itself, there is lot of subdivisions. If same 2 by 2 question is there, na, I will give homework. Da. Let me see. That's what. Let me see. Let me see. Fourth one we have. Fourth subdivision, you can take homework. Pa. Subdivision 4, you can take homework. Same 2 by 2 children. Same 2 by 2. Fourth subdivision, you take homework. Okay. Right. Second one we are going, that is 3 by 3. Have you done, children? Everybody is anyone doing this still? Do fast, pa. Second question will go to Raja. Same 10th Roman, second subdivision we have to go. Right, pa. Listen, ma. So this is given. So let's take that this is as a. So let A equal to the given matrix I'm taking 6 minus 2 plus 2 minus 2 3 minus 1 2 minus 1 3. Sir, this is I'm taking A matrix. Okay, va? Now A dash also we need. If you have seen the sum word, sum of symmetric and skew symmetric word. See, children, sum of symmetric and skew symmetric word. If you have seen, na, surely we need A transpose. So that A dash you have to find. So that A dash which is equal to, here I'm going to reduce a little bit steps, kindly listen. Directly I will be doing the A transpose. So that the row we have tried as a column. The row we have tried as a column, 6 minus 2 plus 2. This second row you take, write as second column. So that minus 2, 3, minus 1. And here 2, 2, minus 1, 3. This is our required A dash. Okay. Now we have to find A plus A dash. Listen, children. A plus A dash is equal to, first you write A matrix. 6 minus 2, 2. Minus 2, 3, minus 1. 2 minus 1, 3. This is A plus A dash. A dash value 6 minus 2 plus 2. Minus 2, 3, minus 1. 2 minus 1, 3. Both just we have to add. That's it. When you add, what you will be getting? Morgana, can you add and tell me? Just tell me. First row alone you tell me. Add and tell me what I'm doing. Add 6 plus 2 what? 12. Okay, that's it. Next. Minus 4. Next. 4. Right, sit down. Sweta, row 2 you tell me. Add. Yes, minus 4. 6. Minus 2. Very good. Sit down. What about Purvika? 4. Yes. 6. Sit down. So I added this directly. I'm adding. I didn't show the steps here. Okay. Now we can multiply 1 by 2 on both the side. A plus A dash is equal to what you will be getting. This also directly I'm going to divide 2 in each of the element. We got to answer. Okay. Divide 2 children. What I will be getting if you divide by 2? 6. No. I'll wait. Who's that? Pridashniya, stand up. Tell me. Divide. 6. Row wise or column wise? Right. 6 minus 2 plus 2, minus 2, 3, minus 1, plus 2, minus 1, 3. Thank you, Pa. So I have done everything. Now this is I'm taking as a letter P, means matrix P. So if you don't want to show more steps, you can do like this also, not an issue. Now we have to check whether it is a symmetric or what. Symmetric, how you will be checking? You have to take transpose. Transpose when you take, you should get the same question. Am I right? Right. So P dash is equal to what I'm getting 6 minus 2 2 minus 2 3 minus 1 2 minus 1 3. When I take a transpose, what I'm getting? Okay. Rajesh, you stand up, tell me this. Take a transpose, tell me, man. Take a transpose and tell me. Row wise or column wise? Row wise or column wise? Row wise. Tell me. Tell me, pa. Huh? Rajesh, I'm talking to you. Can you tell me? Column wise. Tell me anything. 6 minus 2, 2. Okay. Minus 2, 3, minus 1, 2, minus 1, 3. That's it. Sir, what he did, row 1 he took, he wrote as a column 1. Okay. So first column is over. And second row he took, he wrote as a column number 2. Like that, third row he took and he wrote as a column number 3. So we got as it is. Now after writing all those things, when you check, it is look like a question again, so that it will be P. P dash is equal to P if we get. What we can say this? Then yes, matrix P is a symmetric matrix. What we can say? Symmetric matrix. Okay, well, what we can say? Symmetric matrix we can say. Same thing we have to do even for a Q, means Q symmetric. Okay, Q symmetric also we have to do the same. So first is subtraction, A minus A dash. So A minus A dash. So A matrix first I'm writing, here we have a A matrix. This will be A dash. Both we have to subtract now. So that 6 minus 2 plus 2 minus 2 3 minus 1 2 minus 1 3. Okay. Minus what is that? 6 minus 2 plus 2 minus 2 3 minus 1 2 minus 1 3. That's it. So we have to subtract. Directly you can subtract. Be careful when you subtract. So 6 minus 6, what you will be getting? 6 minus 6, 0. Minus 2, when you multiply the minus inside, minus into minus, plus you will be getting. Then minus 2 plus 2, also 0. And plus 2, minus if you multiply inside, this will be minus 2. Plus 2 minus 2, it will be 0. What happened? Everything coming 0. Oh, it's a 0 matrix then. Minus 2, minus 2, minus plus 2, 0. Yes, 0. Yes, 0. Yes. Okay, everything we are getting 0, children. 0 matrix. Okay, if you multiply by 1 by 2, A minus A dash, which is equal to, what I will be getting? Again 0 matrix only. So no change in it. Okay. So 0 matrix also we can say skew matrix. Means if you multiply by what is that something, you will be getting the same. Which I am taking a Q. Okay, which I am taking a Q. So if you take a Q transpose, what I am getting? 0 matrix, if you take a Q transpose now, 0 0 only you will be getting. Yeah. If you take even negative outside, if you take negative outside also what? Yes. So is equal to minus a Q. So Q dash is equal to minus Q now. We will be getting that Q is skew symmetric matrix. Okay, both we got it now. So that some we should get what actually? Question you have to get. Some we should get as a question. Shall we check whether we are getting question or what? Okay, what is the p value? P value as it is. Here we have a p. P value here we have that p matrix you take right here. 6 minus 2 plus 2 and here minus 2, 3, minus 1, and row 3, 2, what is that, minus 1, 3. Q matrix will be 0 matrix. If you want to mention 0, you mention, so that you will be getting the same. Same means what? 6, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, which is equal to actually A matrix. So sum equal to, if we get the A means what? Question. If we get the question, what we can say? We have done. Okay, hence proved. Hence proved. Children, actually Q matrix I got a 0, so very easily I have done. But homework question, I don't know how it's going to come. If it is not, you have to do very carefully here. What I done, the same thing you have to do. Understand? Right. Third one, 3 by 3 matrix. Third one, 3 by 3 matrix. You should take homework. So how many questions I gave then? 3 and 4. Even morning also I gave some question. Yeah, totally 4 questions today I gave. Tomorrow holiday only, no? So that we can. Right, sir? Due to Christmas, they are giving holiday for us. Enjoy your Christmas as well as homework. Right, fine. Shall we? Okay, sir. Have you done, pa? Can I go 11? 11 and 12 what? Huh? MCQ, very good. So almost we are going to complete the third chapter then. That is Thomas exercise, sir. Only one question we have. Miscellaneous also we have. That I forget, Ratanga. Sorry. Right. Okay, pa. Question number 11. 2 more exercise we have. Miscellaneous. Miscellaneous we have almost 11 question. Completed, appa. Girl side, ma. Is anyone writing? Very good. Boy side, pa. Super, appa. We'll go to MCQ question. Eleven and 12. Right. Okay, children, listen. Question number 11. Choose the correct answer in the exercise 11 and 12. If matrix A and B are symmetric matrices of order, same order. Okay. Listen, children, they said A and B symmetric matrices, it seems. So listen first. A, B are symmetric, they said. Children, what is mean by symmetric matrices, pa? Yes, very good, very good. Then A transpose if you take, you will be getting A. Even B transpose if you take, you are getting B. That is the meaning of both are symmetric matrices. Okay, next line. And they asked to check AB minus BA is what? Either a skew symmetric or symmetric or identity or 0. That is they asking. Shall we check? Right, pa. So first you take the given one, AB minus BA. So first option skew symmetric, second option symmetric. Now we should take transpose only to check the symmetric and skew symmetric. For the given question, you take transpose. When I take transpose, if I get inside what we have, if I get the same, now we have to say symmetric, or minus of inside if we get, we have to say skew symmetric. Okay, right. Shall we check? So that first addition or subtraction, listen children, addition or subtraction when we have, if you have a whole transpose, now A transpose plus or minus B transpose. Have you remembered this formula? As per that, what I am going to do, transpose when you bring inside, AB whole transpose minus BA whole transpose you will be getting. One more formula we have, AB whole transpose if we have, it will be reverse, means B dash A dash, means B transpose A transpose. As per that, The AB transpose you will be getting B transpose A transpose minus. What about here? This BA will become A transpose B transpose. Listen carefully. AB became B transpose A transpose. BA became A transpose B transpose. By using this formula, it will become reverse order. Have you noticed it? Be careful, children. Right. Now, in the question, B transpose we can write as a B. Okay. Like that, A transpose we can write as a A. That is they are given. So that what I'm going to write, B transpose we have. B transpose I'm going to write as a B. Like that, A transpose I'm going to write as a A minus A transpose I'll write as a A. B transpose I'll write as a B. Children, you may do mistake. Don't think that BA and AB same. Because already we have seen that in the first exercise or second exercise, matrix need not to be commutative. When it should be commutative, I said, if it is a diagonal matrix, it will be commutative, I said. So if you think if it is the same, you will be giving 0. If you give 0, it's wrong. So you should not give that it is a same. So it never comes 0. It's not a commutative. Okay. So AB not equal to BA. So that don't give 0. Again I'm telling it never be commutative. If it is a commutative, it should be a diagonal matrix. Okay. Right. Now AB BA means what is that? Is that inside one? Is that inside one? AB BA. What is sorry? BA and AB. It is reversed. Have you noticed? If you take minus outside, what will happen? Minus AB will become plus CAB. Plus BA will become, what is that? Minus BA. What, my dear? Minus BA. So that, what actually I got? Actually, what I got? AB minus BA. When I take whole transpose, I got minus of inside what I had. If you get like that, what we can say? Very good. What we can say? Skew symmetric. In the sense you write, if you write P dash is equal to minus P, we can say that which will be skew symmetric. Okay, which will be what pa? Skew symmetric. Then AB minus BA is skew symmetric. So there will be a very big work here. Don't think it will be MCQ. See, it has given a big work. It may come in a 2 mark also. It may come in a 2 mark also. But you must be very clear in that. We got that option A is our required answer. Option A is our required. Skew symmetric matrix is our required answer. Have you noticed it, children? Be careful, ma. Be careful, Raja. I'm going 12th one, pa. 12th one. A matrix given. Just A plus A dash is equal to I they gave. And they asked to find alpha. Alpha value we have to find. Right. A is given. What is A is given? What is A given? Cos alpha minus sin alpha. I hope we have done somewhere else this. Sin alpha and cos alpha. A transpose if we find. So the row we have tried as a column. Cos alpha minus sin alpha. Second row you write as a column. So that sin alpha and cos alpha. Okay. I told you, somewhere we have done. Where in the sense, this is page number 67, 6th Roman. We have a 2 subdivision. In that, there is one of the question. Right. Here they said that A plus A dash is equal to I, it seems. Means when you add, you will be getting identity matrix. So A value, then you do as it is. A value what? Cos alpha, sin alpha, like that, minus sin alpha, cos alpha, plus A dash, means A transpose. Here we have that you write cos alpha, sin alpha, minus sin alpha, and cos alpha equal to I. I means 1, 0, 0, 1. When we have A matrix 2 by 2, identity matrix also 2 by 2. When you add both, what you will be getting? Cos plus cos, what you will be getting? 2 cos. What you will be getting? 2 cos alpha minus sign plus sign 0, minus sign plus sign 0. Here also minus sign plus sign 0 again, 0 again. Here cos plus cos 2 cos. What I am getting? 2 cos alpha. So after adding, I am getting this, which is equal to 1 0 0 1. When two matrices are equal, then their corresponding elements are equal. Have you remembered that word? Have you remembered that? As per that, 2 times cos alpha is equal to 1. First element will be equal. That you make it. So that cos alpha is equal to 1 by 2. Multiple to when you send opposite, 1 by 2. For what angle you will be getting 1 by 2, Raja? Alpha is equal to cos inverse of 1 by 2. For what angle you will be getting 1 by 2? 6, 30 or 60? 60 degree, that is pi by 3. Okay, pi by 3. Where we have pi by 3? Option B is our required. Okay, answer B. Answer B, Raja. So since you mentioned two matrices are equal, then corresponding elements equal. Then their corresponding elements are equal. Okay, that's it. That's it, Raja. This is you will be getting. Okay, this is you will be getting. Do it fast, ba. Ma next 3.4 we have only one sum that will complete. Write fast, children. Okay, pa. Write fast, pa. Write fast, Raja. Two matrices are equal, then corresponding elements are equal. That is the word I wrote. I wrote in a cursive handwriting. Kindly try to understand. Okay, boys. Next, invertible matrices we have to see, Raja. That is theorem number 3. Okay, ma, we'll see in the next class, Raja. Both the things, miscellaneous as well as invertible matrices, we will see in the next video. Okay, thank you, children. Bye, bye.